Hi, we're going to be going through the spring semester exam review. I'm going to be working through all the problems. I'm actually going to do the first couple of pages. A couple of the other teachers are going to do the rest of them. And this will allow you to get help on what you need help with from this semester. To begin, we have the conics. It's not chapter 11. It's chapter 10. Sections 2, 3, 4, and 5. So to begin, it says, write the equation in graphing form of a parabola that has the following conditions. So to begin, let's be reminded quickly about the equations for a vertical parabola. We have x minus h squared equals 4p times y minus k. We have the horizontal, that is y minus k squared, that's messy, equals 4p times the quantity x minus h. That's just in general. So for part A, we have a vertex at -1, 2, so we want to plot that point. And I'm going to call that V for vertex. And then the focus is at -1, 6. And label it F for focus. So automatically I know that this is going to open up. Remember that the parabola contains the vertex. It curves around the focus. The directrix line is behind it. So this is going to open up, which means it's vertical and it's opening up. Just make a few little notes. You know that we use the vertex is the HK, so we're going to be using those points. I circle them because that's going to go in my answer. The only other thing I need to know now that I know it's vertical, I know what H and K are, I need to know what P is. Well, P is the distance and direction from the vertex to the focus. So from the vertex to the focus, we're going up 1, 2, 3, 4. So that means that P equals 4. So to write our equation, we're going to have the vertical. So we have x minus, and so x minus a -1, which is x plus 1, equals 4 times p. Well, p is 4. 4 times 4 is 16, times the quantity y, and then minus the k value, which is a 2, and that is our equation. Next one, the focus is at 3, -4, and the directrix is at x equals 7. So we have a vertical line at 7. So if the vertex is contained in the parabola and it curves around the focus and the directrix line is behind it, then that means this is going to open to the left. So I know it is horizontal, and I just put my little arrow opening left. And where's the vertex located? Well, it is halfway between the focus and the directrix. So that coordinate would be at 5, -4. And so that's our H and K. I'm going to circle those because we're going to need that in our answer. And we also need to know what P is. Because it is opening left, then P is negative, and it's the distance and direction from the vertex to the focus. That's a -2. So we're ready to write our equation. The horizontal is y first, and it's minus k, so that's a plus 4 quantity squared equals -2 times the 4, because it's 4p, so that'd be a -8 times the quantity x minus the h, which is a -5. That's the equation of that parabola. So now if we move on, this parabola, if we look at the equation given, we need to determine some things because we have to graph all of these parts. So this one is horizontal because it is y squared. I know that the vertex, I'll just put a V, is HK, so that's going to be a 2, -2. Remember that H is with the X and K is with the Y. And the P value we're going to need to know, because 4P is -8, then P has to be -2. Because it's horizontal and negative p-value, that means we're going to be opening to the left. So I'm going to plot my 2, -2 point as my vertex. And if I go left 2, I'm going to get my focus. And if I go right 2, I get my directrix line. And remember, from the focus, I need the total focal width to be an absolute value of -8, which is +8. If I go half of that on either side, so if I go 4 on either side, then through the vertex and through the endpoints of the focal width, I draw my parabola opening left. That's it. For part B, this one, because the x is squared, it is vertical. The vertex is going to be located at HK. That's going to be a -3. Remember, H is with the x, K is with the y. It's always the opposite sign because of the minus in the equation. And the p-value, because 4p is 4, then p has to be 1. So I'm going to plot at -3, -1. That's my vertex. And because it's vertical, then p is positive. We're going to be opening up. So we're going to go 1 up for the focus. And we're going to go 1 down for the directrix line. And lastly, the focal width is 4. Absolute value of that is +4. So we're going to go half of that on either side so that we can draw our parabola opening up. Okay, next we're going to talk about circles. The form for a circle, I'll just remind you, the center again is HK, like a vertex was for parabolas. The formula in general for a circle, excuse me, is x minus h squared plus y minus k squared equals r squared. So if we're given the center and the radius, we're just going to be plugging in. We have x minus 2 quantity squared plus y plus 3 quantity squared, and r squared, 3 squared is 9, so that's how we're going to leave it. The origin, if I have x minus 0 quantity squared, well, x minus 0 is just x, so it's really just x squared plus y squared, because y minus 0 squared is still y squared. And then 2 square root of 5 squared. Well, that's either 2 square root of 5 times 2 square root of 5 when I'm squaring it, which would be 4 square root of 25, which is 4 times 5, or 20. Or I can type it into the calculator with a parentheses and the squared on the final outside part of it. So as long as I type it correctly, then the calculator will work for me. But if I didn't put the parentheses around the whole thing, the whole 2 square root of 5, then it won't give me the correct answer. The next part is going to talk about ellipses. So let's be reminded that for an ellipse, we look at the denominator and see where the bigger denominator is located to determine vertical or horizontal. So let me give you a quick reminder of those. When it's vertical, we have x minus h squared and y minus k squared, both for the numerators. But when it's vertical, the a squared is under the y portion and the b squared is under the x. So the other would be when it's horizontal, we have still the x minus h squared and y minus k squared for our numerators, but being horizontal, the a squared is under the x. Whoops. The b squared is under the y. So first off, if the center is at -1, 2, and the horizontal major axis, so we know it's horizontal, is 10. So that means that if I go a total of 10, I need to go 5 on either side. And that also tells me that A would be 5, which is half of the 10, because from the center to one vertex, that is the A amount. They tell us C, so I just rewrote that. And we do need to know our center. That's our H and K for our equation. but I need to know what b is. Well, we have a c squared equation for an ellipse that is c squared equals a squared minus b squared. So when I plug in the values and solve for b squared, just doing this quick, when I get a positive b squared is a positive 16. Remember that b would be a 4, but remember that the b squared is what goes in the answer. So we're going to write our answer. That's a fraction plus fraction equals 1. The center is going to be x plus 1 quantity squared, y minus 2 quantity squared for my h and k. Because it's horizontal, then our a squared is going to be under the x, and the b squared is going to be under the y. This one has a center at 0, 3, vertices at 0, 8, and 0, negative 2. So first of all, this means it is vertical, and the a value, won't go into the vertices, is a 5. And they gave us the foci at 0, 5. I'll label V for vertices and F for foci, and 0, 1. And that's focus. So from the center to a focus is the C value, which is 2. And I need to find, using our C squared equation, and that is 4 equals 25 minus b squared. Subtracting 25, I get negative 21 equals a negative b squared. So b squared is a positive 21. And again, that's what I need to put in my equation. Because it's vertical, we have the a squared being under the y, but we're going to start with our center, and I'm going to circle that. So x minus 0, which I don't need to put the parentheses then. It'll be x squared, y minus 3 quantity squared. And again, vertical, because the a squared is going to go under the y, b squared under the x. Moving along. Here's, we're going to graph these ellipses. So this one, because the denominator, the bigger denominator is a squared, and that means that this one under here is going to be horizontal. And the center, I just put a C and put the coordinate, is HK. So I'm going to take the H's with the X and K's with the Y, but the opposite sign. So our center is at negative 2, 3. And the A, because the bigger denominator is a squared, then A is 6, and B will be 4. So that means I'm going to go horizontally the A amount, both ways, and go vertically the B amount, and then I can graph my ellipse. The next one, because the a squared bigger denominator is under the y, that means it's vertical. Because the numerator has nothing subtracted from x or the y, that means our center is the origin, 0, 0. And a squared being the bigger denominator means a is 5 and b is 3. So we're going to go vertically the 5 and horizontally the 3. And then we draw our vertical ellipse. The hyperbola. Okay, the hyperbola, we have to look specifically at the types of hyperbola that we know for horizontal and vertical. So I'll just make this as a note over here. So horizontal hyperbola is when we have the x minus h squared, y minus k squared. X is first on the top. This one, we look at the numerator to see which is first, x or y. The a squared and b squared are always in the same location for the two types. So vertical is going to be when the y is first on the top. The a squared always is the bottom left, b squared is always the bottom right. So there's just a general rule for hyperbola. The 6A, we have the center given at 1, 4. It's a vertical transverse axis, which is 8. So I know it's vertical. I know my center, which is HK, and I'll need that for my answer. The vertical transverse axis, that's the total, so that means that A would be half of that, which is 4. And they tell us C. Well, we need to know, use our c-squared equation for a hyperbola, which is c squared equals a squared plus b squared. And so plugging in those values, we will be able to solve for b squared, that we can put that in our answer. So we get 20 for b squared. And I have the fraction minus fraction equals 1. Because it's vertical, that means the y comes first. We take the y part of our vertex with it. And then the x part of our, I'm sorry, I called it vertex, I meant center, excuse me. And then for the denominator, a squared is always in the bottom left, and b squared is the bottom right. The next one, we have our center, which is HK, which will go into our equation. If our vertices are at -5, 0 and at 1, 0, if I make a quick little sketch of that, then I can see that from the center to one vertex is going to be 3. So I know that also that it's horizontal because of the direction it is, and that we just said A was 3. And the foci are at -8, 0, and at 4, 0. So from the center to one focus point, that is the C value, which will be a 6 here. And then if we use our c-squared equation, c squared equals a squared plus b squared, and I plug into that, and subtracting the 9, we get b squared to be 27. So we're ready to write our equation. Because it's horizontal, the x comes first. We take the x part of our vertex, excuse me, I keep saying that, excuse me, the center. And then y minus 0 would be a y squared. A squared is always the bottom left, which here is a 9, and b squared is under the y, which is 7 for that. The next one's to graph the hyperbola. We have first, because the x is first, we know that is horizontal. We know our center point coordinate would be HK, which H is with the x, K is with the y. And then the a squared is 16, so a is 4 and b is 5. Because a squared is always bottom left, remember. We have 2, -1, and 2, -1 is our center. Because it's horizontal, we have to go horizontally the A amount and vertically the B amount. And that allows us to draw the rectangle for the hyperbola. Remember, the next thing we do is we draw the asymptotes that go through the center and through the opposite corners of the rectangle. Because it's horizontal, it's going to go through the vertex and approach the asymptotes, opening left and right for the branches. And that's our hyperbola. The next one, because it's y squared, it means it is vertical. Y squared first. The center will be HK. H is with the x and K is with the y. A squared is 9 because it's the bottom left, so A is 3 and B is 6. So we're going to plot -3, 0, and we're going to go vertically the A amount both ways, and horizontally the B amount both ways. And that allows us to draw our rectangle. that we can draw our diagonals that are the asymptotes. And to draw the vertical hyperbola, we're going to draw through the vertices and approaching the asymptotes on each side to have an up and down opening branch. Sorry, I was just making a video for Algebra 2. Can I finish real quick? I'm trying to, I'm on the last couple of problems, so they're standing out there and I can hear them like, she's making a video? Because usually it's for pre-cal, and I'm like, no, it's for Algebra 2. Okay, inverses.
Okay, so on the next part of the review, they're asking us to graph and solve square and cube root functions. On part A of problem 10, they've given us the function f of x equals the square root of x plus 1 minus 3. And I've gone ahead and recognized that the parent function for this graph, or this function, is y equals the square root of x. And you can see that I've graphed it in pink. And let's go ahead and now look at the transformations that need to be applied. Well, this plus 1 tells me I need to shift left 1. And the negative 3 out in the back tells me I need to go down 3. So I'm going to take each parent point of my graph and shift it left 1 and down 3. Okay, so now looking at our domain and range, the purple graph is the one that we're interested in. That's part A, the function given to us. And the domain is my x values, and every point on my graph has an x value that is greater than or equal to negative 1. And my range is my y values, and every point on my graph has a y value that is greater than or equal to negative 3. Okay, moving on to part B. They've given us the equation y equals negative 2 times the cube root of x plus 1. Well, the parent function is y equals the cube root of x. And we're going to go ahead and apply the transformations needed. Well, this negative out in front tells me that I'm going to reflect across the x-axis. And this 2 out in front tells me that I am going to have a vertical stretch of 2. And the 1 out back tells me I'm going to shift up 1. So let's go ahead and apply those transformations. First, I'm going to reflect all of my points. So this one across the x-axis. So this one is up 2, so I'm going to bring it down 2. And let's go ahead and assign each one a color. I'll do my reflection in blue. I'll do my vertical stretch in green. And then my final graph, which I'll shift up, will be in purple. Okay, so let's start with the blue. Let's reflect every point across the x-axis. That's just giving me a mirror image around my x-axis. Notice the point on my origin didn't need to be reflected. It's going to remain in its place since it actually lies on the x-axis. Now let's do our vertical stretch of 2. This one is 2 away from the x-axis, so now I need to make it 4 away. This one's 1 away from the x-axis, so I'm going to make it 2 away. This one stays the same because it's at 0. That one is going to become 2 away, and this one's going to become 4 away. Now, all that's left to do is to shift everything up 1. So I'm going to take those points, those green points is where I ended last, and I'm going to shift them up 1. Oh, I need to change to purple. Shift every green point up 1. Okay, so those purple dots are my final little points, so I'm going to go ahead and erase my blue and green ones. Those are just for y'all to see the transformations. Okay, and then I can connect my purple dots. And that, and I didn't make a very nice smooth curve. Let me fix it for you. Is the function they've asked us to graph in part B. And if we look at it, the domain is all my x values. Well, these arrows tell me that my graph is going to continue to go left and right along the x-axis, so all my points will be all real numbers for my x values. And my range will also be all real numbers since it's going to continue to go up and down. Okay, let's move on to problem 11. They're wanting us to rewrite in rational form the cube root of 2. Well, the thing you need to remember about writing things in rational form is the number out in front of the radical goes on bottom. So this is going to become 2 raised to the 1 over 3. Now, the opposite goes for number 12. They're going to ask you to write it in radical form. Well, that means you have to put a radical or a square root sign. So you're going to take the number on bottom and send it out front. So that's going to be 7, the 7th root of 5x squared. Oh, I'm sorry. I shouldn't have said that. Because the 2 raised to the 7, or the exponent of 2 to the 7th, is only applying to the x. So it's 5 times the 7th root of x squared. Okay, now on this one, in number 13, they're wanting us to simplify this equation. So I'm going to go ahead and take care of my negative exponent inside here. And when you have a negative exponent, you send it down to the bottom. So this you can rewrite as 3 over x to the 5th raised to the negative 3 over 4. Okay, well, we still have negative exponents up here, and it's being applied to this fraction inside of our parentheses. Well, that means that when you have a negative exponent, you can flip the fraction and make the exponent positive. So instead of 3 over x to the 5th, we're going to make it x to the 5th over 3, and the exponent, like I said, becomes positive 3 over 4 instead of negative 3 over 4. Well, now we can bring this number down on the bottom out to the front. So this is going to become 4 raised to the x to the 5th over 3. And remember, we're still cubing that. That cubed part comes from this top numerator of our exponent. So now we can keep going with the 4th root of x to the, we're going to multiply these, x to the 15th over 3 cubed, which is 27. So all I did was apply this exponent of 3 inside. So now what I can do is divide this 4 into this 15. Well, 4 goes into 15 3 times. So when I do that, I'm left over with 3, because 4 times 3 is 12. So, like I said, 4 goes into 15 3 times with a remainder of 3 left over. So what I can do is I can pull out an x to the 3rd, because remember, 4 goes into 3, or 15 3 times. And then what's left over is x to the 3rd, because it has a remainder of 3 over, oh, sorry, we're still to the 4th root, over 27. So all we did there was pull out an x cubed. Okay, now what I can go ahead and do is multiply the top and the bottom by the 4th root of 3. Because that really, the 4th root of 3 is 1 over 27. So here we go. When we do that, we're left with, on the top, we're left with x cubed times the 4th root of 3x squared over 3. Okay, so that is your final answer to number 12. On number 14, they're asking us to graph exponential growth and decay functions. And in part A, they've given us the equation y equals 2 raised to the x plus 2 plus 1. And the parent function is y equals 2 raised to the x, and I've graphed that in pink. Well, this plus 2 with the x tells me I'm going to shift left 2, and this plus 1 out in the back means I'm going to shift up 1. So I'm going to take every point from my parent function and shift left 2 and up 1. Okay, and then you graph it in purple. You can see the new transformed graph, which is the equation they've given us in part A. My domain is going to be all real numbers because it's going to keep going, opening wider and wider to the left and to the right. My range, in this case, is that all my y values must be greater than or equal to 1. Because it has a horizontal asymptote of y equals 1. And that's going to be y equals 1. Okay, now for part B, the domain, or let's go ahead and figure out what transformations we're going to have to make here. Our parent function is y equals 1/2 raised to the x. I've graphed it in pink. This negative out front means I'm going to reflect it over the x-axis. And the minus 3 out back means I'm going to shift down 3. So I'm going to reflect and then shift down. And then you can go ahead and connect these purple dots. And you realize once again that your domain is going to be all real numbers because your points on your purple graph are going to encompass all x values. And the range is y must be less than or equal to -3. Because all of your y values are going to be less than or equal to -3. And the horizontal asymptote is that line, the horizontal line of y equals -3 that won't ever be touched by the graph. So that equation is y equals -3. Okay, let's move on to number 15. It says if the value of a stone increases in value by 2.5% each year, find the value of the stone after 6 years. Well, we're going to use our exponential growth formula, which is a equals p times 1 plus r raised to the t. Okay, well, P is the principal amount, the original value, which is $5.25. R is the rate at which it's increasing, which is 2.5%, but we have to convert it to a decimal. So that's going to be 0.025. And then the T value is 6. So A equals 525 times 1 plus 0.025 raised to the 6. And when you enter that in your calculator, you end up with $608.84. Okay, on number 16, it's the same thing, except this time we're using exponential decay formula because it depreciates. The value of the vote depreciates. So it's going to be A equals P times 1 minus R raised to the T, where our principal amount, the original value of the boat, or car, I don't know why we have two different words there, but the original amount is $28,750. The rate at which it's decreasing is 3.7% each year. When we convert that to a decimal, it becomes 0.037. And then the time that we're interested in is 3 years after the original price. So this becomes A equals 28,750 times 1 minus 0.037 raised to the 3. And when you enter that into your calculator, you end up with $25,675.40. Okay, so now looking at 17, it tells us Pierre's buying a DVD online for 10% off the list price. He has to pay $3.50 for shipping, and the total charge is $26. what is the list price of the CD? Well, if he pays 10% off, that means he's paying 90% of the list price. So, you can start off with the cost equaling $26, and then we convert 90% to 0.9 for decimal form times the list price plus the shipping fee of $3.50. And then we need to find out what the list price is equal to, so we're going to subtract 3.5 from both sides, and you end up with 22.50 equals 0.9 times x. Well, then we're going to divide both sides by 0.9. And when you divide 22.5 divided by 0.9, you end up with x equals 25. So the original list price of the DVD was $25. Okay, for number 18, they're asking us to write in logarithmic form this exponential equation. Well, that's when we're going to implement the log rule. You always start with your base, and our base here is 7. Pick up the other side, and then go back to the exponent. So it's log base 7 of 343 equals 3. Okay, now they're wanting us to write this in exponential form. So we start with our base, and the base here is 2. We pick up the negative 3, and then go back to the number. So it's 2 raised to the negative 3 equals 1 over 8. Okay, on number 20, they're asking us to solve for x. Well, in order to get x by itself, we have to log roll. So we start with our base of x, pick up the 2, and then go back to the 9. So it's x squared equals 9. Well, now we can take the square root of both sides. So x equals plus and minus 3, because square root of 9 is 3. But remember, if you take the square root of both sides of an equation, you have to put the plus and minus. Okay, on part B for 20, we're going to try and get x by itself again. We're going to subtract 3 from both sides first, and you're left with 2 raised to the x plus 1 equals 6. Then we have to log roll. So we're going to start with our base, pick up the 6, and then go back to x plus 1. So it's 2 raised to the 6 equals x plus 1. Well, 2 raised to the 6, I'm sorry, it's got to become, when we log roll from exponential, we have to convert it into a log. So it becomes log base 2 of 6 equals x plus 1. And when you type in log base 2 of 6 in your calculator, you get 2.58 equals x plus 1. And then when you subtract 1 from both sides, you end up with x equals 1.58. And you can check that by plugging it back in, and you should end up with the equation equaling out to 9. Okay, so on part C, we're going to add 3 to both sides. Remember, our whole goal is to get x by itself. So you end up with 4 log base 3 of x equals 28. Then you're going to divide both sides by 4. And you end up with log base 3 of x equals 7. Then you have to log roll. So you get 3 raised to the 7th equals x. So x equals 2,187. Okay, so let's move on to D. We are now going to use natural log because we have an e here. And when we have an e, we can multiply both sides by ln, and that ends up giving me, oh wait, let's see if we can log roll actually. You start off with your base of e, pick up the 12, and then pick up the negative 2x. So it's log base e of negative 2x equals 12. And log base e is the same thing as ln, so it's ln of negative 2 equals 12. Okay, and then for this one, we're going to subtract 2 from both sides. and you end up with ln of x plus 3 equals 11. Then we're going to go ahead and multiply or raise both sides to e. And that cancels these e and the ln, and you're left with x plus 3 on this side equals e to the 11th. Well, then you're going to subtract 3. So x equals e to the 11th minus 3. And when you type that in your calculator, you end up getting x equals 59,871. And let's go ahead and actually go back to part D. I'm sorry. On this case, you're going to multiply both sides by ln. And when you do that, that cancels this e out. So negative 2x equals 12 times ln. Then divide both sides by negative 2. So when you multiply 12 times ln and divide it by 2, and once again, I've messed up. Part D is causing me problems. You're actually going to take the natural log of both sides. So when you take the natural log of e raised to the negative 2x, and the natural log of 12, those cancel out on the left-hand side. So you're left with negative 2x equals the natural log of 12. Well, then you divide both sides by negative 2. And when you type that in your calculator, ln of 12 divided by negative 2 equals negative 1.24. So x equals negative 1.24. Okay, we are going to omit f and g, and let's move on to 21. They're asking us to graph the following. Well, the parent function of this is, let's do it in pink, y equals log base 2 of x. And I'm going to go ahead and graph that. So now you can see our parent function of y equals log base 2 of x. And then let's look at the transformations we're going to have to make. This plus 1 inside with the x tells me I'm going to shift left 1. And this 2 out front means I'm shifting up 2. So I'm going to take each point and shift left 1 and up 2. And when I do that, my purple becomes my new graph. The domain, all of my x values are going to be greater than or equal to negative 1. And my range is all real numbers because my graph's going to keep extending up and down. Oh, I'm sorry, it shouldn't be greater than or equal to negative 1. It should be just greater than negative 1 because it's never going to actually approach this line of negative 1, which tells me also that this is my asymptote. This y equals negative 1 line, I'm sorry, x equals negative 1 line is my asymptote. Okay, so now let's move on to part B and C. Okay, so the parent function for this equation is y equals log base 1/2 x. And let's go ahead and graph those parent points. Okay, and this negative out front means I'm reflecting across the x-axis. So I need to take each point and reflect it across the x-axis. And when I do that, I end up with that purple graph. In my domain, all my x values are greater than 0. My range is all real numbers because it's going to keep extending up and down. And the equation of my asymptote is x equals 0 because that's the line that my graph will never touch. Okay, moving on to part C, let's go ahead and graph our parent function, which is y equals ln of x. And we know that that graph point that we know we can rely on is at 1, 0. Well, this inside with the x, this -3 is telling me I'm shifting everything to the right 3. And then I'm going to shift this -2 out front, means I'm shifting down 2. So let's go ahead and do that. I'm going to take this point and shift right 3 and then down 2. And I'm going to mimic this graph. And my domain for this graph is x must be greater than 3 because I have a horizontal asymptote at 3. My range is all real numbers. It's because it's going to keep getting higher and higher and lower. And then the equation of my asymptotes is x equals 3. All right, let's move on to problem 22. It asks us to factor completely. Well, the first thing I always check for when I'm factoring is a GCF. Well, I notice all these terms have an x. So I'm going to pull out an x as my GCF. And I'm left with x squared minus 7x plus 12 on the inside. Well, now I have a trinomial that I can factor by setting up shop. So I keep bringing down that x. And then I need two numbers that multiply to 12 but add to 7. And those are add to -7, I'm sorry, 3 and 4. And they both have to be negative in order to multiply to a positive 12 and add to a -7. So there is my factor, my completely factored form of part A. Now part B, I look and see there's no GCF, and I also realize that there is 4 terms. Well, when I have 4 terms, I'm most likely going to factor by grouping. So I take the first 2 terms and the second 2 terms and put them together. Then what I go ahead and do is I write them as x cubed plus 9x squared plus -4x minus 36. Then I go ahead and factor each of those individually. Well, I notice in this first set I can pull out an x squared as a GCF. And that leaves me with x plus 9 on the inside. And then the common GCF of the second term is a -4. So I go ahead and pull out that -4, and I'm left with x plus 9 on the inside also. Well, now if you notice, this term has an x plus 9, and this has an x plus 9. So I can go ahead and pull that out. So I pull out an x plus 9 out front, and what's left on the inside is x squared and -4. So I can go ahead and multiply the x plus 9 that I pulled out by x squared plus 4. Oh, I'm sorry, x squared minus 4. Well, in here we notice that x squared minus 4 is a difference of perfect squares. So we keep bringing down that x plus 9. And remember, a difference of perfect squares, you put the square root of the first term as your first base, the square root of the second term, which is 2, as your second base, and then one gets a positive and one gets a negative. Okay, on 23, they're asking us to state the maximum number of possible terms and the left-right behaviors of the following polynomials. Well, to state the number of maximum possible terms, we look at the highest exponent, and in part A, that's 4. Well, max terms is always the highest exponent minus 1. So in this case, it's 4 minus 1. So 3 terms is the max terms. And then we look at whether the degree or the highest exponent is positive or negative. Well, in this case, now we need to figure out if left or right is going up or down in this curve. Well, To figure out the left side behavior, we look at the leading coefficient. And in this case, the leading coefficient is, y'all, I'm sorry, scratch that. Let's go ahead and put left and right in here. And you always have to find your right behavior first. And the way you find your right behavior is you look at the leading coefficient. So the right is leading coefficient. And if the leading coefficient is negative, your right side behavior is going to go down. So in this case, it's negative, so it goes down. Now, if it's even, the signs are going to match. So if the right goes down and the degree is even, then it's going to match the right side behavior. So in this case, the right went down and the degree was even, so the left went down also. Okay, now for this one, remember the maximum number of turns is 1 less than the highest exponent. So the maximum number of turns is 4. The left side and the right side, remember we look first at the leading coefficient, and the leading coefficient is positive. So the right side's going to go up, and the degree is odd because it's 5. So if the degree is odd, remember odd for opposite. So that means it's going to have the opposite behavior of the right side, so left is going to go down. Okay, so now I'm going to pass it on to Ms. Suderman to finish this out. Good luck studying, y'all.
Okay, so this is now Mrs. Suderman, and we are on page 5 of 6 of your review packet. So number 24, it says you can use polyroots on your calculator to help graph the following polynomials, or you can solve it the way that I'm about to. So on 24a, we have x cubed minus x squared minus 9x plus 9, and whenever there are 4 terms, it's a good idea to see if it works by factoring by grouping. So you would group the first 2 terms together, you group everything in pairs. So then your GCF for this first part, your greatest common factor, is x squared. When you take that out, you'll be left with x minus 1. Do the same thing with the second part. Always take out the negative in the number that's in the front, so minus 9. And then when you take out the minus 9 from this second part of our cubic function, you'll be left with x minus 1. Then looking across, both parts have a GCF of x minus 1. So I take out the x minus 1, then I'm left with the x squared in the front, and then the minus 9 for the second part. But that's a difference of perfect squares. So I'll have x minus 1, x plus 3, and x minus 3. So then if you remember to set each of these things equal to 0 and solve for x, this first one will get an x value of 1, and then you'll get, for the next one, negative 3, and then for the next one, positive 3. So we have 3 zeros for our function, which matches our degree. We have a cubic function of 3, a power of 3, so then we have 3 zeros. Your y-intercept is always going to be this last number, this constant term without a variable sitting here at the end. So our y-intercept will be at 0, 9. So we'll want to start out by graphing our zeros. So we've got zeros at 1, 1 to positive 3, and 1 to negative 3. And then our y-intercept is at 0, 9, so that's up here. Okay, so this is a positive function. The leading coefficient is positive, so that means the right side will go up. And because the degree is odd, that means the left side will do the opposite and go down. So if it's an odd degree, the arrows go in the opposite direction. And then from that point, we just go through all of our points that we have on the graph, and there you go. Okay, but for 24b, we have x cubed plus x squared minus 10x plus 8. Given that x minus 1 is one of its factors, this one you still have 4 terms, but if you tried factoring by grouping, it wouldn't work. But because we know that x minus 1 is one of its factors, you could either do long division, and you can see that on your answer key, or you could do synthetic division. So this x minus 1 means I'll have a positive 1 right there. And then let me write down my coefficients, making sure I'm not skipping any exponents. So we have 1 x cubed plus 1 x squared minus 10 x plus 8. So then you draw your line, bring down the first term, so we have 1, and then multiply it. So 1 times 1, you get 1. Now add them together, you get 2. 2 times 1 is 2. Added together, you get negative 8. Negative 8 times 1 is negative 8. Add it together, and you get 0. Because it told us that x minus 1 was one of its factors, we already knew that this remainder should be 0. So then this is 1 degree less than what we started with. So this is 1x squared plus 2x minus 8. So now I have x minus 1. I divided that out, and when I divided it out, I was left with x squared plus 2x minus 8. And then you think, does that factor? Is there anything that multiplies to negative 8 but adds to positive 2? And yes, we have x minus 1 times x plus 4 and x minus 2. So then if you set each of those factors equal to 0 and solve for x, for the first one, you'll get x equal to 1. Then you'll get x equal to negative 4, and then you'll get x equal to 2. Your y-intercept is your constant term sitting there at the end, so you'll have 0, 8. So plot the zeros on your graph at 1, 2, and then negative 1, 2, 3, 4. Your y-intercept is at 0, 8. Plot that point. Okay, so again, this one is positive, so that means the right side would go up. If it were negative, the right side would go down. The degree is odd, so the left side will do the opposite. If it had been even, the left side would have done the same thing as the right side. And then we just go through the points and connect them. And there's your graph. Again, looking at this next function, we have rational functions. So let's start graphing. So you have 1 over x minus 3 plus 1. Your vertical asymptote you can tell by looking at what's in your denominator here. And so then that would be the vertical asymptote. Set it equal to 0 and solve for x. You get x equals 3. For the horizontal asymptote, you look at this last number right here. So we went up 1. So remember that for your parent function, you have asymptotes at x equal to 0 and y equal to 0. And then your graph kind of does this sort of thing. So then if we've moved it, anything with the x, remember that's the left and right, and it'll be the opposite. So minus 3 means we went to the right 3, and then this plus 1 means we went up 1. So the asymptotes would do the same. The vertical went to the right 3, and the horizontal asymptote will go up 1. Y equals 1. So then for the domain and range, it's going to be all real numbers except where our asymptote is, x will not equal 3. And then for the range, it's also going to be all real numbers except for where our asymptote is at y cannot be equal to 1. So if we want to graph this, our vertical asymptote is at x equals 3. So right there, I'm just going to put a squiggly line so you can see it. And then the horizontal asymptote at y equals 1. Okay? And then we're just going to roughly sketch these, and that's fine. So we'll have the points didn't get stretched at all. So we have 1 right there, and we can go like that, and then like that. So there's our function. Okay, and then for the next one, here we went to the left 1, we went down 3, but we also got reflected over the x-axis and stretched by 2. So then our vertical asymptote, so we went to the left 1, is going to be at x equals negative 1. Our horizontal asymptote is at y equals, because we went down 3, it's at negative 3. Our domain will be all real numbers except for x cannot be equal to negative 1. And then the range will be all real numbers except for that y cannot be equal to negative 3. So putting the asymptotes on the graph, so we have x equals negative 1. Y equals 1 to negative 3. Okay, so if we had points that were, if you pretended like that were the new origin, at 1, 1, and negative 1, negative 1. That 1, 1, its y value will get multiplied by negative 2, so we'll now be down here. So it got flipped over there. Okay, and what used to be at negative 1 is now at negative 1, positive 2. So it got flipped over there. Not the prettiest graphs. Okay, next section. Okay, this section is about variation and rational equations. So number 26, you have the time t it takes a salesman to drive to a sales call varies inversely as the average speed r. It takes a salesman 4.75 hours driving at 50 miles per hour. So because we have this as varies inversely, so our first variable will be, inversely is y equals k over x. Okay, so if we have the time t varies, the k always goes after the equal sign, and it varies inversely as the average speed r, so that means the r will be in the bottom here. Okay, so what is the constant of variation k? Well, if we know that it takes 4.75 hours driving at 50 miles per hour, we'll have 4.75 equals k over 50, and then if you multiply both sides by 50, that'll leave you with k is equal to 237.5. So then to write the variation equation, that just means you're going to fill in this k value, but you're going to leave the t and the r there. So we'll have t equals, now we know that k is 237.5 over r. So we just fill in the value for k. Then how long would it take to drive at 60 miles per hour? So we have t equals 237.5 over 60, and then when you divide that, you get 3.9583333, so 3.96 hours. On number 27, the lateral surface L of a cone, so there's our first variables, we'll have L equals, the k always goes after the equal sign, jointly as the radius of the base r and the slant height L. So we'll put times r times little l, okay? And so L equals 63 pi meters, square meters when r equals 3.5 meters and L equals 18. So it gives us an almost complete scenario here where we just have to find the value for k. So if L is 63 pi, we don't know what k is. We know that r is 3.5, and we know that L is 18. So if I just simplify that a little bit, I get 63 pi equals k times 63. So then if I just divide both sides by 63, I get that k equals pi. So now I know that L equals, my k value is pi, and then we have times r times little l. So find r to the nearest tenth when L equals 8 pi square meters. So there's filling that in. We're looking for r, and our little l is 5. So then here, if we divide both sides by pi and by 5, then you get r equals 8 over 5, or you could say that's 1.6, and that'd be meters. Okay, so for this part, we are going to be solving for x. So we've got some rational equations here. So what you want to do is look at, alright, so on this first one, I think what would cancel out this denominator, and that'd be an x, and what would cancel out this one by multiplying, and that would be a 7, and I have to multiply this one by 7x to cancel everything out. But I need all of these things on the top to match. Well, I've got a 7x here, so this has a 7, but it'll need an x, and this has an x, but it'll need a 7. So now I'm looking across the top. I will cancel out whatever matches, so the x's match, and then multiply whatever's left over. So I have 21. And then here the 7's cancel, so I'll have plus, multiply together what's left over, 5x equals, and then this one, the 7x's cancel, so I'm left with 2. So if I subtract 21 from both sides, I'll get 5x equals negative 19. So then x equals negative 19 over 5, or negative 3.8. Okay, on 28b, first of all, factor this denominator, so I have x plus 4 and x minus 4. And now I think, what do I need to multiply by to get rid of all of my denominators? So here I would need to multiply by both the x minus 4 and the x plus 4. This one would need an x plus 4, and this one would need the x minus 4. But I need all of the top parts here to look the same. So this one, I'll add on there an x plus 4. This one needs the x minus 4. And now all of the top things look the same, and I can start canceling things out. So cancel out whatever matches the x minus 4's match and multiply whatever's left over. So I have 6 times x plus 4 distributed, so I'll get 6x plus 24. Here the x plus 4's cancel, so 1 times x minus 4, so I'll get plus x minus 4. And then here the whole thing will cancel out, so I'm just left with x. So 6x plus x, you get 7x, and 24 minus 4, you get 20. If you subtract the 7x over, you'll get 20 equals negative 6x. Divide both sides by negative 6, and then you get x equals 20 over negative 6 reduces to negative 10 thirds, or you could say negative 3.33. And now for the multiple choice section. 29, in the diagram below, the plane y is perpendicular to the axis of the cone z. So this dashed vertical line here, that's our axis. And then this plane is perpendicular to the axis of the cone z. So whenever it slices through it, it's going to make a circle. On number 30, identify the conic section that the equation 2x squared plus 12x minus 3y squared plus 50 equals 0 represents. So if you look, we've got to only look at the x squared and the y squared terms. You only have to look at these two terms right here. These two numbers are different numbers, and we have different signs. So when that happens, anytime you have a different sign, that means you're going to have a hyperbola. So this is a hyperbola. On number 31, we're going to identify this conic section. So all you have to do is look at the squared terms. So we have 2x squared plus 2y squared. Whenever you have the same sign and it's the same coefficient, the same number, so these are both positive 2, think that's the same all the way around, so that would be a circle. On number 32, in the diagram below, the plane J is neither parallel nor perpendicular to the cone K. So that means whenever this plane slices through the cone, it's going to come in at an angle here, and it will make an ellipse. On number 33, identify this conic section. Looking across for the squared terms, we only have one squared term. And so anytime there's only one squared term, that means you're going to have a parabola. Number 34, looking for the squared terms, we have a 4x squared and a plus 8y squared. They're different numbers, but they have the same sign. That means that this will be an ellipse. For number 35, in the diagram below, plane M is parallel to the axis of the cone A. So whenever this plane moves over, you'll end up seeing something like that, which is going to be a hyperbola. And then number 36, in the diagram below, plane M is parallel to the surface of the cone A. So plane M is parallel to the surface of the cone A. As cone A and plane M extend indefinitely into space, they will eventually intersect. Which conic section will be formed? Whoops. And we're back. Whenever they intersect, when it's parallel to this outside edge, that is going to create a parabola. Okay, you've made it to the end. Good luck on your finals, and I hope you've had a good year in Algebra 2. Thanks for watching. Bye.